Article 392 of the National Electrical Code, or NEC, provides the requirements for using cables and cable trays. It's important to understand that while 1/0 AWG cable has certain applications, smaller gauge cables are also permitted under specific conditions. Section 392.10b emphasizes that conductors and cables installed in cable trays must be listed and marked for use in cable trays. This means the cable manufacturer has specifically tested and approved the cable for cable tray applications. This listing ensures the cable can withstand the environmental conditions, mechanical stresses, and potential heat buildup within a cable tray system. Section 392.10 code directs users to Table 392.10 code, which identifies the types of conductors and cables permitted in cable trays. This table is crucial because it outlines the specific cable types that have been deemed suitable for cable tray installations based on their construction and performance characteristics. While 1/0 AWG is not explicitly listed, the table does include various smaller AWG sizes, thereby indicating that cables smaller than 1/0 AWG are indeed permissible under the NEC. The table lists numerous cable types approved for use in cable trays. Firstly, armored cable, or Type AC, is permitted in accordance with Article 320. Secondly, metal-clad cable, or Type MC, as per Article 330, is allowed. Thirdly, fire alarm cable, as covered in Article 760, is also an option. Fourthly, instrumentation tray cable, or Type ITC, is suitable as described in Article 727. Fifthly, power and control tray cable, or Type TC, can be used as outlined in Article 336. Sixthly, other factory-assembled multiconductor control, signal, or power cables specifically identified for the use are permitted. Seventhly, single conductors are allowed if they are insulated and listed for use in cable trays. Eighthly, shielded power cables rated over 2000 volts are permitted. Ninthly, there is exception number 1, which says that only where the cable is direct buried from equipment and is run in a cable tray for support. The cable must comply with Part 2 of Article 310. Tenthly, there is exception number 2, which says that cables suitable for exposed wiring is permitted. Some additional considerations are important when selecting and installing cables in cable trays. The ampacity of conductors in cable trays must be determined according to Section 392.11. This section provides guidance on calculating the allowable current carrying capacity of cables in cable trays, taking into account factors like the number of cables, ambient temperature, and spacing. Proper cable support and securement are crucial to prevent strain and damage. Section 392.8 outlines the requirements for cable support, ensuring cables are adequately supported and secured within the tray to prevent them from sagging or being damaged. Furthermore, cable fill requirements, as outlined in Section 392.9, must be adhered to. This section limits the amount of cable that can be placed in a cable tray to prevent overcrowding and ensure adequate ventilation. Overfilling a cable tray can lead to overheating and potential safety hazards. Additionally, it's vital to maintain proper bending radii for cables to avoid damage to the insulation and conductors. The NEC specifies minimum bending radii for different cable types, ensuring that cables are not bent too sharply, which could compromise their integrity. Also, grounding and bonding of cable trays are essential for safety. Article 250 provides the requirements for grounding and bonding, ensuring that cable trays are properly grounded to prevent electrical shock hazards. In summary, cables smaller than 1/0 AWG are permissible in cable trays, provided they are listed and marked for such use, are of a type identified in Table 392.10 Corn, and are installed in accordance with all applicable requirements of Article 392. Understanding these requirements is crucial for ensuring a safe and compliant electrical installation. Cable trays offer numerous advantages in electrical installations. Firstly, they provide a flexible and adaptable system for routing cables, allowing for easy changes and additions as needed. Secondly, they offer superior cable management compared to conduit systems, making it easier to identify and maintain cables. Thirdly, they can support a large number of cables, making them ideal for installations with high cable density. Fourthly, they provide excellent ventilation for cables, reducing the risk of overheating. Fifthly, they simplify cable inspection and maintenance, allowing technicians to easily access and inspect cables. Furthermore, cable trays come in various materials and designs to suit different applications. Common materials include steel, aluminum, and fiberglass, each offering different levels of corrosion resistance and strength. Designs include ladder trays, solid bottom trays, and ventilated trays, each with its own advantages in terms of cable support, ventilation, and accessibility. When selecting a cable tray system, it's important to consider the environmental conditions, the type and number of cables to be supported, and the accessibility requirements. Also, proper installation techniques are essential for ensuring the safety and reliability of a cable tray system. This includes proper support spacing, securement of cables, and grounding and bonding of the tray. In addition to the NEC requirements, it's also important to consult local building codes and regulations, as they may have additional requirements for cable tray installations. Local codes may vary depending on the jurisdiction and the specific type of installation. Failure to comply with local codes can result in fines and delays. When working with electrical systems, always prioritize safety. Wear appropriate personal protective equipment such as gloves and safety glasses, and follow lockout/take-out procedures to prevent accidental energization. If you are not qualified to work on electrical systems, consult a licensed electrician. Proper training and experience are essential for ensuring a safe and compliant electrical installation. Always refer to the latest edition of the NEC for the most up-to-date requirements. The NEC is updated every 3 years, and it's important to stay current with the latest changes. Online resources such as the National Fire Protection Association website offer access to the NEC and related information. Understanding the NEC requirements for cable tray installations is crucial for ensuring a safe, reliable, and compliant electrical system. By following the guidelines outlined in Article 392 and consulting with qualified professionals, you can ensure that your cable tray installation meets the highest standards of safety and performance. Let's delve deeper into specific aspects of cable tray installations and the relevant NEC requirements. Regarding cable types permitted in cable trays, the NEC provides a comprehensive list in Table 392.10 Cone. This table specifies the allowable cable types based on their construction and intended use. For example, Type TC cable or tray cable is specifically designed for use in cable trays and is commonly used for power and control circuits. Type MC cable or metal-clad cable is another popular choice due to its robust construction and suitability for both exposed and concealed installations. Other cable types listed in the table include armored cable, fire alarm cable, and instrumentation tray cable. When selecting a cable type for a cable tray installation, it's important to consider the specific application and the environmental conditions. For example, in corrosive environments, it's important to use cables with appropriate corrosion resistance. Also, in areas with high temperatures, it's important to use cables with high temperature ratings. Furthermore, the NEC requires that all cables installed in cable trays be listed and marked for such use. This listing ensures that the cable has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or UL. The listing mark indicates that the cable meets the applicable safety standards and is suitable for use in cable trays. Regarding cable fill requirements, the NEC sets limits on the amount of cable that can be placed in a cable tray. These limits are designed to prevent overcrowding and ensure adequate ventilation. Overcrowding can lead to overheating and potential safety hazards. The cable fill requirements vary depending on the type of cable tray and the size of the cables. For example, for ladder-type cable trays, the NEC specifies a maximum cable fill based on the cross-sectional area of the cables. For solid-bottom cable trays, the NEC specifies a maximum cable fill based on the depth of the tray. When calculating cable fill, it's important to include all cables in the tray, including power cables, control cables, and communication cables. Also, it's important to consider the spacing between cables. The NEC requires that cables be spaced adequately to allow for ventilation and to prevent overheating. Regarding cable support requirements, the NEC specifies how cables must be supported within the cable tray. Proper cable support is essential to prevent strain and damage. The cable support requirements vary depending on the type of cable and the type of cable tray. For example, for large cables, the NEC requires that they be supported at intervals not exceeding a certain distance. For small cables, the NEC allows for longer support intervals. Also, the NEC requires that cables be secured to the cable tray using appropriate fasteners. The fasteners must be designed to withstand the weight of the cables and to prevent them from slipping or falling out of the tray. Regarding grounding and bonding requirements, the NEC provides detailed requirements for grounding and bonding cable trays. Grounding and bonding are essential for safety, as they help to prevent electrical shock hazards. The NEC requires that cable trays be grounded and bonded in accordance with Article 250. This article specifies the methods for grounding and bonding different types of equipment, including cable trays. In general, cable trays must be grounded to a grounding electrode system such as a ground rod or building steel. Also, cable trays must be bonded to other metal parts of the electrical system such as conduit and enclosures. Furthermore, the NEC requires that all grounding and bonding connections be made using approved methods and materials. The connections must be tight and corrosion resistant to ensure a reliable electrical connection. In summary, cable tray installations must comply with a wide range of NEC requirements, including requirements for cable types, cable fill, cable support, and grounding and bonding. By following these requirements and consulting with qualified professionals, you can ensure that your cable tray installation is safe, reliable, and compliant with the NEC. Also, it's important to note that the NEC is not the only standard that applies to cable tray installations. Other standards, such as those published by the Insulated Cable Engineers Association, or ICEA, and the National Electrical Manufacturers Association, or NEMA, may also be relevant. These standards provide additional guidance on cable selection, installation, and maintenance. For example, ICEA standards provide detailed specifications for different types of cables, including their electrical and mechanical properties. NEMA standards provide guidance on the design and construction of cable trays. When designing and installing a cable tray system, it's important to consult all applicable standards and to work with qualified professionals who have experience in cable tray installations. This will help to ensure that your cable tray system meets the highest standards of safety and performance. The information provided serves as a general guideline and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or licensed electrician for specific design and installation requirements. Adherence to local codes and regulations is also crucial for ensuring a safe and compliant electrical system. Continuous learning and staying updated with the latest industry standards are essential for electrical professionals. This includes attending training courses, reading industry publications, and participating in professional organizations. By staying informed and continuously improving your skills, you can provide your clients with the best possible service and ensure the safety and reliability of electrical systems. Electrical safety is paramount, and all work should be performed with the utmost care and attention to detail. Proper planning, execution, and verification are essential for preventing accidents and ensuring a safe working environment. Remember to always de-energize circuits before working on them and to use appropriate personal protective equipment. The NEC and other relevant standards are constantly evolving to address new technologies and safety concerns. Staying abreast of these changes is crucial for maintaining a safe and compliant electrical system. Regular review of the NEC and participation in continuing education programs are highly recommended. The installation of cable trays must adhere to Section 314.2080 for any boxes or conduit bodies that have conductors over 6 AWG. These must adhere to specific dimension requirements. For boxes or conduit bodies enclosing conductors 4 AWG or larger, the minimum dimensions of the box or conduit body are specified to provide adequate space for the conductors and their connections. This requirement helps to prevent overcrowding and ensures that there is sufficient room for proper installation and maintenance.